Hello, Victor here to demo our latest power sizer tool. In the first panel, we can define our vehicles. Here we have a baseline vehicle, the GM ISV Heavy, compared against a serial hybrid Fairing Pioneer X from the UK. We can look at different vehicle specs as you'd find on a spec sheet, and we have powertrain suppliers incognito under A, B, and C variants, which can be interchanged. We can also be a little bit more advanced to look into aerodynamics, rolling resistance, and powertrain layout. In the next step, once that is done, we go into the mission. Here we have defined 3 mission vignettes, one in the Middle East, one in Greenland, and a third one in Europe. So what does this do? For example, in the Middle Eastern mission, we have a total range of 2,000 kilometers. This tool allows us to tweak this mission. It allows us to define halt duration at any given point, any export power that needs to be charging equipment, launching at that point. We can also say this bit here needs to be in silent mode. There's a certain gradient. And again, we need to charge. We have a certain EV load on this distance. So as the user is then able to play around with this, the mission is defined. And the critical cost, of course, comparing combustion versus hybrid or full electric is recharging cost. Here we are working with 3-4 scenarios. So we have helicopter, of course, the most expensive one, convoy, pre-positioned or forward refueling points. Same works in the table. Everything works back to the map. You can define your terrain type, sand, gravel road, which feeds back to the overall efficiency. Especially snow in Greenland, of course, is a lot resistance and consumes a lot of energy. Once that is done, the user then goes into the results view. So we have here defined, for example, the vehicles on the left, we have the mission in the middle, and we have the business case on the right. So we can see the total mission cost for the GM is 770,000 compared to 45,000 on the Fairing, mainly driven by the fuel consumed and especially the refueling events because of the significantly smaller fuel tank by the GM Heavy compared to the Fairing. Also interesting here is then what is the fuel at the end of the mission and what could that mean if the vehicle carries on, continues the mission, or has some excess energy here to be used. If we want more details, we can see the full profile where on the right we see the fuel of the Fairing carrying out throughout the mission, and the bigger battery, smaller fuel tank, GM, consumes a lot of fuel when the bigger battery needs to be charged. We can go into further details here. Okay, that was it. Hopefully this tool helps enable disruptive technology on the market where it can show total mission cost and benefit and not just look at the one-off. All right, take care. Bye-bye.